Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here. It's our second video on displaying sets in Venn diagrams. Let's start with something we've already done. We've already answered a question like this, so pause the video and double check you can do this with ease. So hopefully you would have got the following picture there. First step, list the universal set, then list the elements of A and B, and then draw your Venn diagram. In this video we're going to draw slightly more complicated Venn diagrams that involve 3 sets. So let's go straight into it. It's the same idea. Pause the video and why don't you have a go at this yourself. Okay, step 1, as I said, always list out the universal set here. The positive integers less than or equal to 10, so they are as follows. Now we've got 3 sets A, B and C. We have the elements within A, B and C listed to us already, so we don't have to work them out or anything, which is great. Let's just think, we're obviously going to have 3 circles for each of those. Let's just have a think how they're going to overlap with each other just before we get going. Can we see an element that's in A and in B, let's say? Do they share anything in common, these two? Well, they both got a 5 and they've both got a 6, so they certainly have stuff in common. Does A and C have anything in common? Well, they've both got 1s in them and they've both got a 5 in them as well. Okay. Now does B and C have anything in common? Let's have a think. Well, they've both got a 5 in them and they've both got a 9 in them. Okay, so A has stuff in common with B and C and C have something in common, and also all 3 of them have a 5 as well. So all 3 of them have something in common with each other. So therefore we're going to draw our Venn diagram like this. A rectangle obviously with 3 circles. Now we're going to make the circles overlap in this way. Now let's just think what we're going to put in each one. Let me label this one A, let me label this one B, and this one C, and let me call this the universal set. Now this part here are going to be the elements in A, B and C. Now we can only find one element in A, B and C, it's 5. So we're going to put that slap bang in the middle there to say that 5 is in A, it's in B and it's in C, and it's in all of them at the same time. Now what we're going to do is we're going to think to ourselves, right, what elements are in A and B alone but not in C? Now the elements in A and B, they both got a 6 in them, so a 6 must go here. Now what elements are in B and C alone? Well, the element in B and C alone is the 9. That is in B and C but not in A. So 9 will go here. So let's tick these off as we go along. So we've got ourselves those done. A and C, what elements are in A and C? Well, A and C both have a 1 in it. They've both got a 5 in it, but the 5 is also in B. So we're just going to put the 1 here to represent the 1 is in A and C but not in B. Okay, if we left anything out, let's go back to the set A. We've put 1 in, we haven't put 2 in, so 2 is an element that's just in A. We haven't put 3 in, 3 is an element that is just in A. We've put 5 in here, and we've put 6 in here, and we're done. What about B? We've put 5 in, 6 we've put in here, 7 or 8 we haven't put in, so they should go here, 7 and 8 go here, and 9 we've put in over here already. Let's go down to C. 1 we've put in, 4 we haven't talked about at all, so 4 must go here. It means 4 is in C alone. 5 we've put in, and 9 we've put in there. So we're almost done. We just have to double check we've got all the elements in the universal set. We've talked about 1, we've talked about 2, 3, 4, 5, 6, 7, 8, 9. The only element we haven't talked about is 10, which must go outside here. And that there is our Venn diagram. Now remember what each bit means. This 5 in this overlap for all 3 A, B and C means 5 is in A, B and C. This bit of the overlap here means 1 is in A and C but not in B. This overlap here means that 9 is in B and C but not in A. This overlap here means that 6 is in A and B but not C. 2 and 3 are just in A alone, 7 and 8 are just in B alone, 4 is just in C alone, and 10 is in neither A, B nor C. Right, last one. Pause the video and have a go at this one yourself. Okay, let's list the elements in the universal set psi. They are the integers bigger than or equal to 1 and less than or equal to 16, so they are as follows. Okay, now let's try and list the elements in each of the sets. Set A, they're the prime numbers, less than or equal, bigger than or equal to 1 and less than or equal to 16. So the primes here must be 2, 3, 5, 7, 11, 13 as follows. B's are the odd numbers, so the odd numbers, they're going to be 1, C are the set of x such that x is less than 10. So the numbers less than 10 here, well, they're going to be and we've listed everything there. Now let's just have a think about overlapping, etc. The first thing is, can we think of some elements that are in A and in B? So 3 is in A and B, 5 is in A and B, 7 is in A and B, 11 is in A and B, and 13 is in A and B. Alright? Do we have anything that's in A and C? Well, 2 is in A and C, 3 is in A and C, 5 is in A and C, 7 is in A and C, and that's it. Now can we think of anything that's in B and C as well? Well, 1 is in B and C, 3 is in B and C, and don't forget it's in A. 5 is in B and C, and don't forget it's in A. 7 is in B and C, and don't forget it's in A. 9 is just in B and C. 11 is in B and A, remember we already had that. 13 is in B and A, we already had that. So we've got everything that we need there. So there are some elements in A and B, there are some in A and C, there are some in B and C, and there is some in all of A, B and C. So we've got the overlap as we had in the previous diagram. So let's start off with a picture like that. Here is our universal set. Why don't we call this A, this B, this C. Okay, what were the elements we said were in A, B and C? Well, we said clearly a 3 was in all of them, so that must go here. We also said a 5 was in all of them, so that goes here. We also said a 7 was in all of them, so that goes there like that. Okay, now 2 here is in A and C, so 2 must go over here. So now we've dealt with 2. 11 is in A and B, but not C. So 11 is in A and B, it goes here. 13 is in A and B, but not C, so it must also go there. Now we've done all the elements in A. Now let's think about it. B, we've got a 1 is in B and in C, so we've dealt with that there. It goes here. A 9 is in B and C, so it must go here. And the 15 is left over, so the 15 must go up here like that, and we're done with that. And then let's think of the elements left over in C. There's a 4, a 6 and an 8, and the only options for that are 4, 6 and 8 here. Now we're nearly done, other than to say what elements should be written outside here in the universal set. We've dealt with 1, we've dealt with 2, we've dealt with 3, we've dealt with 4, 5, 6, 7, 8, 9, now 10. I can't see a 10 in here anywhere, so 10 must go outside. 11 is dealt with. 12 is not, so 12 should go out here. 13 is, 14 is not, so 14 should go out here. 15 is here, but 16 is not, so we put a 16 here. And that there is our picture for this example, and we're done. Thanks very much for watching.